Hello everyone and welcome back to this new LabV webinar. My name is Charles. I'm one of the two founders of LabV, and today I would like to give you a live demo with some focus on it. And the focus is going to be how to use data and turn them into a better decision. So we're going to go through the software. I'm going to give you a little bit of outlook as well on how to use data and AI in future to make predictions. We will look at it as well. But before I start, first information, this webinar is being recorded, so you will get an email with the recording and the slides afterwards. Don't worry if you miss anything. And at the end of the session, we will have the possibility to use the Q&A session feature here to ask and answer some of your questions. For those who don't know who we are, LabV is a company of the Netch Group. That's why the reason why you got the invitation from Netch Analyzing and Testing. We collaborate very closely with them for years now. So every 4, 6, 7, 8 weeks there is a LabV webinar, and we also come from the industry, and everything we do is for the industry. What do I mean by that? The mission of our company, we are a software company, is to accelerate material innovation for a European industry that keeps shaping the world of tomorrow. And we really want to redefine how material innovation and formulation development is being done in Europe. Our software platform makes all the data you need, material data, test results, and so on and so forth, usable so that you can develop your products better, in a better way and faster. We want to support you to be able to make data-driven decisions, but we also have kind of a hidden mission, if I can say so. We want to open up the access to future technologies such as AI, which we're going to talk about today, for companies of all types and all sizes. We think it's not fair that only the largest companies can use these new technologies, so it's very important to us to make it accessible for everyone. What am I talking about here? Exactly. So there is one big challenge or two challenges, depends how you want to describe it. There is definitely one reality in Europe right now. In the R&D, and doesn't matter if the R&D and the lab are the same department or different departments, but in the R&D with the lab included, every engineer, chemist, chemical engineer, whatever the profile is, loses roughly 45 minutes per day searching data. Which means if you take a team of 10 experts, 10 engineers in your R&D team, then it's 1,650 hours per year, which means one full-time engineer, only looking for data, and data you already have, by the way. On the other hand, these experts, they're also retiring, and in Germany only, because we are a German company, we looked at the numbers, but it's the same everywhere in Europe. Just in Germany, between 2026 and 2036, 20 million workers are going to retire. Knowledge, if you use Microsoft Excel as your main tool, your operating system, the knowledge is going to disappear with every expert retiring or leaving the company, which means as a company, you have a 0% return on investment because you invested the whole career to build up knowledge, and the knowledge goes with the person. So you have nothing left. And it's important thing because there is a lot of Europe bashing going around for a month now. The European industry, in my opinion, is not falling behind because they don't have data. It's falling behind because they don't have access to the data. And that's a big difference. Our solution, we call it the material intelligence platform. It's an intelligence layer with a system of records, so a database for industrial R&D. In LabV, and we will look at it in a minute, you have all the data you need, material process test results, you have workflows from project management to lab management, but also AI components. It could be generative AI, it could be predictive AI, and it's an R&D agent at the end of the day. And we're going to deep dive into that in a minute. Just to give you an idea of what everything we're going to see now has a value, and the value is the 45 minutes you can cut by 2/3. So it's 66% less time searching for data. You can cut the documentation effort by 50%, and at the end accelerate your time to formulation or time to product We could even say time to market if you want by 30%. Enough with the slides, let's jump into the software. In my demo system, I would like to show you first how, maybe give you a quick tour, like how is it built? The solution has basically four main elements. The first one being the resources. It's basically everything you need to conduct your projects, your experiments, and develop your products. Then you do the projects for that. You have a data hub with a data search function, which we will look at today. And you have an AI assistant, which we will look at afterwards as well. So these are basically the four main features of our solution. I don't want to give you a full demo, it doesn't make sense, but so that you understand how it's built, everything is revolving around these four central elements. Let's start with the resources. I'm going to stay here in the material library and I want to highlight something. Using data also means, or in the first place, in my opinion, it means using the right data, being up to date. Over 50% of our customers manage their raw materials in the ERP system. Could be SAP, Microsoft, or a specific solution. It doesn't matter. This shouldn't change because that's where you have the prices. That's where controlling and production and logistics, everyone in the company, every department involved gets the information from. But what it means is in LabV, if you have an ERP, we synchronize with the ERP, and the list you see here would be basically just a display or a copy of the list in the ERP system, which means every day you get up in the morning, you go to the office, you go to your lab, and you work with the current raw material price. You don't have to think about it. You don't have to search for it anymore. It is always up to date. If you look at the details here, just open the first one. You see all the information you need. Every single data point, every single metadata is available within a click, basically. The biggest value in being or using up-to-date data is that, first of all, you don't do mistakes anymore. And second, there is no double work. You don't have to enter data into two systems if the ERP system is the central one and it's going to be and stay the single source of truth. That's how it works. Now, for the companies and the people here who have no ERP system, well, we can do everything in LabV. You just create materials. It's probably ideal if you define a certain specific role for that so that not anyone can do it. And then there is the hybrid solution, which is I have an ERP system, but it's only for production material. I also have my own R&D material. For example, I want to qualify or characterize something. I want to compare something new to have a substitution potential and so on and so forth. Well, in this case, you would have both. This is the list of the ERP. You create your own R&D ones here, and then we use a certain type of categorization. It could be colors, it could be different menu. Doesn't matter so much how we implement it. All right, let's go now to the project. I'm going to open you this project and show you a little bit of information. It's also data use in some way, but just to give you an idea, in the description field, you have the description of the project and also the objectives, so the target, which means everything I know about the project and what I want to achieve is documented in the database and linked to everything else as well. Now let's go into the work mode. That's basically the everyday menu for most of the users. From left to right, each column is an experiment. And from the top to the bottom, you have a formulation, which is my target formulation. You have some calculations based on this formulation. Then you have a process. Then you create a sample, and this sample is going to be measured and tested in a lab. Okay? Now, if I open the sample on it, the interesting part is usually when you work in Excel, you document as much as you can or as much as you want, okay? In our case, everything is documented. And you probably have seen that before. You create a recipe, you create a formulation, you're at your desk, and then you go to the lab, and then you prepare your experiment. And then you see that, Well, I wanted to do 42.3 grams of this one, but I actually only did 42.2 or 35 or 45. And this is something you usually don't really document. You document either or, but not both. In our case, everything is documented so that whenever you look back at the results, maybe you do the interpretation of the performance at the end after the lab results came back. You look at it and you can actually make the link between what was the target and what is the actual percentage or amount value that we reached in preparing the sample. And this is a huge difference because now it's real data. There is nothing missing. It's real data. Everything has to be documented, and it's the same, by the way, for the process variation. In case you were dispersing something here, and the dispersing time was not 30 minutes, but maybe 25 or 28 or 32, and it has an influence. This does influence the result. Then you're able to retrieve this information and use the data for that. So that's in our view one of the most important values of how to use data properly in day-to-day work. Now, if I open this, I obviously have 21 experiments, and 21 experiments times how many is it? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 21 times 12 single results that I want to look at. Okay. Well, I just go on the graphic, like on the chart mode, and I can create my own charts. For example, show me the gloss results for the 21 samples that I created. Actually, it's 22 samples. You can see here there is one experiment with 2 samples. Or show me the color difference. I could also do, I don't know, the price per kilo, depending on the depending on one of these properties. It doesn't matter what I want to do. I can change it within clicks, bar line scattered. I can choose here something as instead of having the experiment, or here instead of having the gloss, I could also just, I don't know, the hardness, for example. I could do exactly the same, right? So it doesn't matter so much. It's very within few seconds and milliseconds I can use my data to have first the overview of the current status, which is very important because 21 experiments is kind of a small project. It's probably rather 50 to 100 plus, and month of work and working with other colleagues on top of it. So it's kind of difficult to keep the overview and keep stay posted basically. Maybe I would call it a nice feature, like nice to have feature. We call it the filter function, and filter function allows me to focus on what I'm doing. So it's using the data a little bit differently. It's using a focused data set, basically. So I could say in this project, I don't want to work on the 21, I want to work on 1, 3, 4, and 12, right? And then I don't see the rest anymore. I could also filter my own experiments. And this is also like I can use whatever the data I want when I'm thinking, when I'm analyzing. I don't have to always be distracted by all the results. And I think it's not exactly using data, I'm aware of that, but it's somehow um, um, yeah, it's an adjacent way of using the data, and I wanted to show that as well. Of course, I could keep doing, you can click on the click here, download the report, and you're using the data as well, but it's actually more using the system to create a project report. But it's basically that's the way you use data, right? Using the structure and using very easy and smart features to create overviews and in between results. Now let's go back. Let's switch a little bit to the assistant. I'm staying in the same project, and I did prepare something. Um, the assistant is kind of your most experienced, knowledgeable colleague in the department. On this digital, and you have to text and chat with it. So the AI assistant, think of it as a chat GPT without any internet access, no access to the outside world, only to your own database. So it's basically using a large language model mapping that into the database, and bringing in the large language model capabilities on top of it. So if you ask what a dispersion agent is, it's going to have an answer to it. But the most or largest use is really more, the first question is kind of a descriptive question, like describe me the project, give me some details, right? 20 seconds. And then you can ask something a bit more complicated. What's the best, which of the dispersing agents we use in the formulation in this project gives me the best combination of three properties? And then you get an answer that is pretty detailed, because it tells you what there's one property is identical for all four experiments that you have mentioned. So I'm going to look at the other one, and the trade-off is only between two and not three. And there is one giving you the best gloss, the other one giving you the best color deviation. But at the end, there is the one here, anti-Terra 250, is better because it has the lowest color difference, which we want to achieve. But the gloss is basically the highest and the best, right? So it's something I can probably do it myself, but I would have to click. Imagine if you do that in Excel, you have to find and create an Excel file to look at the data next to each other. It's really complicated. In LabV, it's a matter of seconds. And then you can go deeper and deeper and more complex questions, variation of one ingredient or raw material between different experiments, and the impact on VOC content and also another property. Then you can use the experiment available and the result to create or calculate a correlation. Of course, I could also put the correlation in the diagram, but I didn't do it. But the correlation has been calculated here. And using this as a base, I also asked, like, can you plot a scatter diagram with the gloss and the hardness on two different, on the horizontal and vertical axle, and then add a trend line to that. So I can also have, because I didn't show it, within a couple of minutes, I do have a very deep interpretation. I can zoom in, look at some points, and maybe identify something, right? So just to show you that there is a new way with artificial intelligence based tools to use your data in a very efficient manner, and it's really having access to all kind of knowledge all around your data, and that's why we call it material intelligence. It's bringing intelligence around your own data. Now, before I switch to the next part, I want to show you something, because the question comes over and over again. What's the difference between ChatGPT and having the AI assistant in LabV? So we did a benchmark. The project I was showing you, we used this data, we exported everything in an Excel file and gave that ChatGPT. On the other hand, the project, exactly the way where we were here. So exactly this situation here, we opened the assistant and created a chat with 6 questions. And the 6 questions were exactly the same in our assistant and in LabV. Okay? So we asked, it's actually one question, but we asked to summarize the project and then explain the result. It was one question. That's why you see 7 lines and not 6 here. We have to say summarizing a project is actually a little bit better, because ChatGPT has a tool that is meant to create very long answers, gives you a very, very long answer for something that is not that complicated. You probably know it yourself, and it does it exactly the same way. So it's gonna kind of, I'm not gonna say it's hallucinating, but it's kind of inventing a little bit of context without having any. And it's kind of making out of a one word, it makes you a whole sentence. So it's a little bit longer. I would say advantage here is probably ChatGPT. The project results, though, it's a tie. It's exactly the same. Focuses on the same insights, the same data, exactly the same metrics. The analysis, analyzing question, here, no big difference, so it's also a tie. Of course, we have additional considerations in LabV that ChatGPT cannot have. But the next part is the most important part because this is just describing, analyzing, but interpretation part. Every time you ask a question to make an interpretation of your data, there is a clear advantage with our solution. Why? Because it has more context and it has historical data on top of it. So it's a little bit different because ChatGPT reads columns in an Excel file and looks at it and has no, it doesn't get the whole context in the same way. In our case, the assistant knows every single link between all the single data points. So we are much better. And if you look at it, basically, ChatGPT is providing good reasoning. That's of course, but there is a limited database. So it's very generic and it has more assumptions in the background. Whereas our assistant is deriving every answer directly from the project's data. So it's really data driven. And that's, in our opinion, the huge or massive advantage here. Wherever this direct access to the project context and data makes a difference. So for critical decisions, I would say, or critical interpretations, ChatGPT or Claude or Mistral or whoever it is will not be able to help you further. All right, let's go back to the solution. One more point I want to show you, it's the data search. Imagine, think of it as your Google search engine, just again, only for your data and no access to the internet. It's the searching engine or search engine for your whole history. So it's basically your digital memory, if you will. I did prepare a couple of different searches. So you can see here, I want to search all the test results in my database that have a VOC content superior to 30. I could do here 100 and it's probably less. Yeah, it's only 18 left. And I could create charts if I want. I could say the sample number and then here the VOC content, right? So I could create charts within seconds, historical charts, trends, whatever it is. But I could also just say, I got a call from a supplier and this blanc fix material is not available anymore. So we will have issues at some point. I have to do some reformulation work. How many formulations do we have in the database with this ingredient in there? So we do a search, you see 76 results. And I could also filter at the end and say, well, I want to look at the price per kilo of this formulation because the most expensive ones are probably the ones I want to, the most critical ones for us. I want to start with there. Of course, I didn't filter, but I should filter here between production and R&D formulation because the R&D ones, I don't care. They were experimental ones. So here, data search, very quick search engine, very easy to use. What's the value here? Well, very quick starting points for a project, super quick and easy to find. You can create from that a task list of things to work on, formulations and projects to work on. You could even prioritize your projects as well. But at the end, it's not just that. To me, it's really having access to the whole digital memory, the digital brain of your R&D or lab team over the last years. That's the most interesting value. And that's the biggest use of the data you can do actually with our solution. Now, this was today. Tomorrow, which actually already started, but we're talking about doing predictions. So you have heard about design of experiment, I guess, which is a statistical approach on how to try to statistically calculate which experiment should be conducted in the future. It has been around for a long time. It's being used by some companies. It's not really wide adoption somehow because the products, the software solutions are kind of expensive. It's complex and it's expensive to use because DOE would give you 150 experiments to conduct. And there is no real priority in there. So you have to do 150 to find out how good they are. What we do is we use the database we have, so your own database as a customer, and then we add a machine learning AI layer on top of it, which is a combination of different technologies. It's not pure machine learning as we know it. And what I do is basically use historical data. So you can see here, this customer had 190, I think. Yeah. At the end, after prioritization and cleaning, it's actually 98 experiments that we used, including their measurement results. Okay. And then we give the frame. So we frame the thing. First, the design parameters. Do I have some raw materials that are fixed or required with a range or fixed value? Some are maybe excluded. Then, what's the target? I want to have contrast, gloss, and viscosity in some range. And I have some constraints. It could have a price constraint. I'm not supposed to have a formulation or recipe more expensive than €5 per kilo, for example. It could be a VOC content, for example. It doesn't have, because regulation says it doesn't have to, it cannot be more than 30 or 20 or 25. Everything, these are basically parameters we can adjust and then start training. Training means we do a run. A run is basically asking the system how many recommendations for do I want to get. So the first run we did 2 recommendations, and the system is going to basically be trained with your data. So there is a space here, right? It's the playground with targets and constraints. I do my runs. The system is using historical data and different approaches, make some calculations and predictions. At the end, I get some recommendations. 5 uh, experiments have been recommended, okay? And from the 5, I can just pick up the one I want. Now, maybe on this one, you see it better. If I take only the 2 most valuable recommendations, compare the recommendation, so the prediction and the actual result in the lab. And you see the difference is not very high. If you look at the graphic, it's actually pretty confident. So over the line is overconfident. Under the line means it's underconfident, meaning the system is kind of telling you we need a little bit more data for that. But the prediction here is very close to what has been measured in the lab, which means a formulation has been recommended or predicted, and the tool said for the contrast value on an 8 square meter wall, you will probably achieve 98.72. The chemist at our customers took the formulation, mixed it, prepared a sample, went into the lab, measured the contrast, and came up with 98.25. This is what you see here. Okay, so left is the machine and right is the actual lab result. Now, if I do that 2 or 3 times, every time I'm using this new data input to optimize my prediction algorithm, which means over time within one project, I'm getting quicker and quicker and more accurate, but also I'm creating optimization algorithm for a specific formulation or product, recipe type or category or family, which means I'm getting for the future for every single product in this category better and more accurate as well. And the interesting part here is, okay, we have good results and we can predict. That's mathematics and technology. But what is very important to me to mention is compared to a typical machine learning project, which nobody can afford except for the very large international multinational companies, with this one, we needed 100 experiments. And actually, the chemist told us you would have saved 100 experiments. So with the tool beforehand, at the beginning of the project, you would have probably saved months of work, probably 6 to 7 months, 100 experiments, which means we're talking about the time to, I was gonna say time to product or time to result, because the market is production as well. But the development cycle is reduced by probably 70%. And that's the expectation we have. Cut everything that is, in this case, a chemical stuff reformulation should not take more than a couple of hours. We're not talking about days and weeks anymore. We're talking about hours, which means you take time off this low innovation level work, and then you put it back onto the actual real new developments and innovative products, right? That's the whole idea behind it. And if you add the price optimization at the end, and you can think of the whole potential we have with this type of tool. This is reality. I'm saying it's tomorrow because tomorrow it will be a feature. Now we work on projects with customers, so if you're interested in that as well. It's a different type of data use, right? It's using the data, historical data, and technology to predict the future and be quicker. So it's kind of a difference. The best combination though is having both. You do structured work, you create your database in LabV as we've seen here, and then you add the prediction side, which makes you quicker for a specific type of project. All right, that's pretty much it for me. You have the possibility to ask questions. If you have some, use the function on the top. I'll mute for a moment. If not, I will end today's presentation in a couple of minutes. Thank you very much for the participation. Thank you for following us and following what we do. I'm looking forward to your email or to your answer to my email very soon and get in touch with you. There is no secret costs or whatever hidden costs. It's completely free. Just talk to us if you need something, if you have questions. We are here for you. We're happy to support you. Looking forward to get in touch with you very soon. Have a nice summer.